All right, let's get started. Hello, everyone. This is modern UI development with Node.js. So my name is Ryan Anklam. I am Bittersweet Ryan on Twitter, GitHub. If you have any questions about this presentation, please tweet at me. If you love to talk about JavaScript, anything JavaScript related. Sorry about that. I'll talk as loud as I can. Again, I'm Bittersweet Ryan on Twitter. If you'd like to talk about JavaScript or have any questions about this presentation, feel free to tweet at me, and I'll be happy to answer any questions. So I am a UI engineer at Netflix. Who here is a Netflix subscriber? All right, so good. We have a lot of great shows. If you're not a subscriber, come talk to me, and I'll do my best to convince you to be a subscriber and maybe come work for us as well. Oh, we pay very well. I could promise you that. So before we go ahead and talk about the future and modern UI development, let's just take a trip back and talk about kind of the past and how we ended up to where we're at. So Tim Berners-Lee writes HTML. The first web page is launched. Oh, my dates are missing on here. I think they're down here, so I can't even tell you when this stuff happened. So somewhere down the line, Netscape introduced JavaScript. Cold Fusion came out and started making us write interactive web pages very easily. That's how I got my start in web development, was with Cold Fusion. Then Microsoft releases XML HTTP. We start getting all this great interactivity on the client. jQuery and Firebug come out, right? And now our client applications become really powerful. We can debug them. We can write them really easily with less code. The DOM isn't so hard. The next iteration, Chrome comes out, and now we got these really, really powerful debugging tools. JavaScript becomes faster, lets us write more and more powerful applications. Node comes out, we can write JavaScript on the server. Grunt, now we start having tooling in JavaScript. Michael Jackson says universal JavaScript is better. And now we come to this whole isomorphic universal JavaScript, and now we're writing JavaScript on the client, we're writing JavaScript on the server, and we got this whole nice ecosystem all in JavaScript. And that's kind of where modern UI development is now, and kind of we don't leave JavaScript and write all of our stuff in JavaScript. The end. This thing went a little crazy, so let's back up. Wow. All right. Let's skip to the next slide. And I'm going to do this manually now. All right. So what exactly is modern UI development with Node.js, right? So is it transpiling our code using things like Babel or less? Is it tooling? Is it using Grunt or Gulp to create these nice build tasks for us? Is it using Node to serve pages like Express or something like that? Is it server rendering, right? Are we doing a template compilation on the server and sending that down to the client, right? It's all those things, but with one slight exception. It's kind of putting all of these things together in one unified workflow. So it's not running JS hint in your IDE or something like that. It's not just running Grunt when you have to push code to a repository or something like that. It's kind of putting it all together and using it as in your entire workflow and integrated. So every step of the way, you're doing all of these steps. So of course, since we're all programmers here, this all starts with the code. So the code is the most important part. And the most important part of that code, and step 0 is where we all like to start, obviously is using modules, right? So use modules. That is the most important thing. An IIFE is not a module, right? The revealing module pattern is not an actual module. It's just a kind of way to get around what we didn't have back in the day. So now we actually have modules. We have ES6 modules. We have common JS modules. Use those, embrace them, use them on the server, use them on the client, right? So both of these are actual modules. It doesn't really matter which one you use. They're both great. There are some pluses and minuses to each different type, but just pick one of these and use them. So ES6 modules, right? They're an ECMAScript spec, so you get the benefits of having ECMAScript behind it. The browsers will eventually implement ES6 modules. It's coming really, really slow. It's coming a lot slower than a lot of the other new technologies in browsers, but eventually they're going to get there. One thing I really like about ES6 modules, they're strict mode by default. So you don't have to remember to write use strict at the top of your ES6 modules. They also give you named imports and exports, which is another really nice thing that you can use. But there are some downsides. So the ES6 spec itself was under a lot of churn for a while. So we'd write some code using the current spec, and then it would change. So you'd have to rewrite your code and change your code. Again, the browser support, it's really coming along slowly. Transpilation, so if you're writing ES6 modules, you're going to have to transpile them back to CommonJS if you want to have a single, or write all your code in a single module pattern. And you can't conditionally load ES6 modules, which can be kind of yucky at times, especially if you're doing some dynamic things on the client and on the server. So CommonJS, it's the Node.js default module system, so you get a huge ecosystem right out of the box when you start using CommonJS modules. It gives you a single syntax for all modules, so if you start using CommonJS, you don't have to worry about writing different code for the client and the server. You can just use a transpilation step, and that'll convert it to something that the browser can use. And you get conditional loading, so you can do a lot of dynamic things that you can't do with ES6 modules. Some of the downsides of CommonJS, it's not strict mode by default. So you have to remember to do use strict if you want to opt into strict mode. Again, you'd have to do that different syntax if you're writing for the browser and for Node. You can get around that with transpilation, but still there is some differences there. And then conditional loading, it's a double-edged sword. Right? So if you're trying to conditionally load a file that isn't there and something breaks and you're not handling it properly, you can blow up your whole application. And if you didn't see Alex's talk before that, you would know how to actually handle these requires. So let's talk a little bit about ES6 or ES 2015. And this is a really, really important point. And that is the code you write today is going to be the code that is going to be copy and pasted tomorrow. Right? So let me ask you a question. What is the first thing a developer does when they start coding in a new project? Right? They find a piece of code and they Control-C and then they Control-V. So recently I was reviewing a pull request from a new team member, and there was this module that he wrote, and everything was wrapped in an IFI. And I asked him in this pull request, I said, why did you have to wrap this in an IFI? Isn't there a better way to do this? And his response, he said, I don't know, that was just the way it was, so I copied it and pasted it. This is a really smart guy. This is a guy that's, we brought him into Netflix because they ask a lot of questions, and they think for themselves, but still, we found that pattern in our code. People see patterns and start to copy that. So that's why it is really important to start writing ES6 today. And even when you go back and refactor some code, bring ES6 into that and refactor it. Because the code that sits there, someone's going to find it, and they're going to copy it, and it's going to make its way into production. So I know you've heard this a million times at this conference, but it definitely is worth saying again. Babel is ready now. We can use Babel. It's really good. Now, I don't want to get into a full ES6 talk, kind of deep dive here. But one thing I do want to talk about in ES6 is classes. And there's a lot of controversy about classes. Some people love them. Some people hate them. Some people say, prototypical inheritance is enough. Inheritance is enough. But specifically, what I want to talk about classes is UI components. If you're using a framework, React, Ember, anything, it's really beneficial to use classes for your UI components. And I have one really good reason for that. And that is you need to let go of your mix-ins and your object.extends patterns. They are very dangerous for one very specific reason. There is a bug in this code. I'm not sure the people in back can see it, but this is just a React mix-in. And if you're not that familiar with React, basically it's just an object that you can mix into a class, and it'll inherit whatever methods that are on that object. So here we have a variable that's just an object called UI messages, and it has a property called get messages, add message, and delete message. And here we have another mixin called message bus mixin. It has an add event property and a get messages property. And we're going to mix both of those in to whatever React component we're creating. Now, does anyone see the bug here? Yes. Get messages, right? When I call get messages in this component, which one's going to get called? Which one do I expect to get called, right? Some frameworks like React will actually warn you if you try to mix in a component that has two of the same properties, but not all of them will. Some will just silently overwrite the first one that was in there, and the second one wins. So mix-ins and extends are dangerous. There's another really subtle point to this slide here. These aren't even really mix-ins or anything to extend, right? They're not doing anything special. They're just message buses and kind of a variable to store messages. These are actually modules, right? So this should just be a node module that we can require and just call properties on. It doesn't need to be a mix-in or an extend. So a lot of the code that we're writing that's mix-ins or that we're extending, it doesn't actually have to be part of the UI component. It should just be abstracted out into another higher level and make it just a regular module. So another thing when we're writing UI components, and a good goal to achieve, is to have a UI composed of only components. Now it takes a little bit to get there, and we even had this problem a little bit at Netflix. So I'm from the acquisition UI team, so we handle all of the sign-up process, and we handle the accounts page. Recently, we refactored this page off of a Java JSP into using React and Node. So the very first iteration, we had this really kind of generic modules. We had a my account page component, and then we had account section components. And we wrote that, and it looked good, but we realized there was a little bit more room for abstraction here. So the next thing we did is, well, these are kind of account header components over here, and then each section can kind of have a little bit broken down a little bit better, right? So we have a payment section and an email section, a streaming section, DVD section, things like that. After we got there, we said, wait a minute, we can do better than this even. And we went back, and our next iteration, everything on this page is now a component. Our links are components. Our input box is a component. Our button's a component. This, our profile image is a component. And you can see we actually reuse that same component way up there in the corner. So we get some code reuse out of all of these components. Now these are used almost everywhere on the website, and it's a lot easier to get a consistent look and feel. When you start reusing these components, you learn the APIs, you don't have to start guessing, and it helps you develop a lot quicker and with a lot less bugs. So now let's talk about your build process a little bit. This is a really, really important part of developing now, right? Because we're doing a lot of things with our build process. And one of the things about our build process is it doesn't get the amount of love and attention that it needs. So the build process is actually the foundation for all of your development. You need to treat it that way, right? It needs to be written just like you would any type of production code. So make sure you break everything up properly. Make sure your build process is as fast as it can be, right? So once it starts getting slower, people start having less fun coding, and they're not spending as much time doing the things that they like and writing code properly because they're waiting for build processes. They're getting frustrated. So one thing I like to think about build process is each step of your process should be a module. And again, if you did any kind of reading on modular programming, each module should only do one thing. So for example, let's say we have a build process with a module called JavaScript, and it does transpiling, it does linting, it does minifying or anything like that. We don't really need that to be one module. We should have a transpile module. So in React's case, we have a React module. Then we have a linting module, and then we have a build or a minification module, something like that. And then you can put all those together using your build process and just create in tasks to put those modules or those pieces together instead of doing it all in one single module. So one rule of thumb here is if you have to require more than one plugin, so if it's a grunt plugin or a gulp plugin, you might want to create another module. Another thing to make your build process a lot easier is to save all of your globs in a separate JSON file and use that to require into your modules. So instead of having to rewrite your paths over and over again, or if paths change, you don't have to go in and look, do a search and replace. You can actually just change your glob in one place, and all of your build process will take care of that. Another really neat thing you can do with your build process is use it to automate mundane or easy to forget tasks. So at Netflix, we actually have tasks to add users to our GitHub repo, because it's a process we don't do very often, and we forget how to do it. Instead of having to look that up, we can just do, gulp, run, add user to GitHub. We have tasks to add Git hooks, so we have pre-push hooks that I'll talk about a little bit later, but we can add those with a single gulp task. We have a task to actually start our local development environment with all of the configuration options we need, so we don't need to remember all those configuration. We can just go ahead and run a single command and get our development environment going. So another part of kind of the build pipeline is testing, right? It's really, really important. Everyone talks about it. Not everyone really does it. And it shouldn't just be done in a single place. So some people just test as you code, right? You'll have a watch task, and as you save, it'll test. But you should test as you code. Test before you push, right? So make sure that you're not breaking any tests before you push it up. And take that one step further and actually test on your CI server as well. So we run unit tests in 3 places. Basically in the terminal where we're writing code, if that module changes, it'll go ahead and run the test for that module. And before we are actually allowed to push code up to our repo, it'll go ahead and run the entire test suite before we push it up. And then once our CI server catches those changes, before it actually pushes that build out, it's going to run those tests as well. So we try to really make sure that our tests are run in multiple places so we don't let anything slip. So testing, again, the big thing about testing is you have to make it easy, or nobody's going to do it. So if you have to do a lot of things to actually get a test going, no one's going to do it. They like to do things that are easy. So easy testing is fast, right? So your tests have to run really, really fast. No one wants to wait for their tests to run before they can do something else. Easy testing is automated. So the least amount of keystrokes to actually run your tests and get results is going to make your test easy. This next one's really important, easy to bootstrap. If it's really hard to set up your test, if you have to write all these mocks and stubs and things to get a test going, even a simple test, no one's going to do it. So try to find a way to reduce that friction. Create a module that mocks and stubs all your common APIs if you have to. And lastly, have a culture of testing. So if everyone tests and everyone starts bugging other people to write tests, then more people are going to do it. So on pull requests, if you see a pull request without tests, without proper test coverage, you can go ahead and bug someone and say, hey, I'm not going to approve this pull request until I see some tests here. Right? That's a really important thing. We all need to be sure that the code rewrite isn't going to break something else, and testing is one of the easiest and quickest ways to do that. So along with testing, let's talk about code quality, another really important thing. So we use ESLint for code quality. And a lot of people, they know that they lint, they know that they should lint, they bring a linting plugin into their IDE, but they don't really embrace it. So why do you want to lint, right? The first one is obviously catch common errors. The second one, with ESLint, we can actually enforce coding standards, which is really good. We've had tons and tons of long email discussions about coding standards and how they should be, but it really helps us bring forward a good conversation, and we all came to something we can agree upon. All the rules we don't enforce very strictly, like white space or tabs and spaces. We're not like that, but we do make sure that we do some common things using coding standards. And this last one is probably the biggest win for me, because I've actually pushed a console.log statement to production once, and all of a sudden I started getting all these bugs assigned to me that our page wasn't working on IE8. And that's because I pushed a console.log. So our linter now will not let us push a console.log statement to test. So we have to remove those. It'll say no log. Same thing with debugger statements. So there's ESLint is probably the one that's taken over, and it's the one we've chosen because it does have a style checker. JS hint doesn't let us check styles. It's pluggable, so you can install plugins. It's future friendly. That was really big for us because we are starting to write more ES6, and we write a lot of JSX. And this last one is really nice, this configurable rules. Because what we do is anytime we change a rule or bring a new rule in, we always set it to warn. So we give people time to actually go ahead and fix their code or fix any errors that we have before we turn it into an error. So we bring it in and we warn for about a week or so, and then after a week we turn it into an error. So also we should lint our CSS. And I only have one really, really good reason why you should always, always lint CSS. And that is because nesting is the worst thing to ever happen to CSS. CSS should never, your less or your SCSS, it should never, ever, ever look like this, right? Because what happens when you want to override the rule that's underneath this bracket right here? You have to include all of those other rules, and then you have another bracket, and then another one, and it keeps getting worse and worse and worse, right? And it's like a virus. It just keeps getting harder and harder to override these classes. So if you do one thing with CSS linting, make sure you catch specificity errors like this. So never, ever let lint errors into your repos, right? That way we can make sure our repo's clean. Everyone that comes in, checks out a new project, that code they're going to copy and paste is free of linting errors at least. Now, how do we do that? We use push hooks. So forget, there's a lot of different hooks that we can have. There's a pre-commit hook, a pre-push, a pre-rebase, commit message, post-update, post-checkout, and post-merge. The pre-push hook here is your nope button. So if you have this pre-push hook and you have it run all of your linting, all of your testing, someone will not be able to push to your remote repository unless they do this. Then you just push up and everyone else can get angry and flip a table. However, if you add testing and linting to your CI server, then they can push that code up there, but they're going to get caught out by that CI server. And public shaming is probably the best motivator you can have to have someone not do something. So if they push a broken test, if they push something that doesn't pass linting up to that repository, your CI server can email everyone on the team and say, hey, this person broke the build. This is why they broke the build. Again, this is something that we want to automate because it's really easy to forget how to do. And it's really easy to not want to do it if it's hard. So all we do, this is how we actually automate our Git hooks here. We just create a task called hook, require a symlink to a Git hook directory that has our hooks, and we just go ahead and actually automatically copy them out of our repo into that person's .git directory. And now no one has an excuse for not having their Git hooks installed and not running their Git hooks. Did you run gulp hook? Well, no. Well, go do that, and now you have all your hooks you need. So the last part of this whole thing is serving up pages. Right? And we're going to use Node to do that instead of the traditional web app way. So traditionally, how we would do this is we would have our business logic, maybe some SQL statements in PHP or ColdFusion if you're like me. Right? And you're going to go ahead and do that. You're going to compile your template with all that business logic kind of in it. You might separate it out by a MVC or something like that. And then you're going to go ahead and run some JS on the client to make that interactive. The problem is with this type of workflow is there's a large context or a large cost to context switching. If you're writing JavaScript 1 minute, PHP another minute, SQL another minute, right? Every time you switch languages, you lose all the context you had in your head for the previous language. So I can't count how many times I've actually added semicolons to Groovy code where I didn't need to, or broke things by using the wrong syntax, writing PHP with dots instead of the arrows. So the modern UI, right? We're going to JavaScript everything. All we're going to do is write JavaScript. There's no more context switching. We're just going to call some RESTful APIs, compile a JS template on the server. Now we're going to use something like handlebars or Dust on the server. And we're still going to have that interactive JavaScript on the client, but we never have to leave JavaScript for this. Right? There's two important rules when kind of starting to think this way, though. And the first one is don't implement business logic in Node. Push that all up to that RESTful API layer. But we do want to implement display logic. Right? So all we're going to do is just make calls to async services, get that data back, compose a template, and send the response. So we're going to spend very little time actually in Node doing anything. A lot of that time is going to be spent waiting on those RESTful APIs to actually implement the hardcore business logic. And then we're going to use all the display logic can be in our templates. Right? But that's good, but it can get even better. So what if all we had to do was call RESTful APIs and write JavaScript? Right? So this is what we call isomorphic JavaScript, or unimorphic JavaScript, isomoral JavaScript. Or we can just all start calling it universal and make Michael Jackson happy and everyone else that's on the universal JavaScript wagon. There's one thing about universal JavaScript, and anyone that's seen a demo of universal JavaScript thinks, this looks super easy. It's not easy. It is actually very difficult to do properly. Calling a template with some data to produce markup, that's really easy. Right? Dehydrating our data in Node and rehydrating it in the browser is actually really hard. Getting data from the right context can also be really hard. Right? So some of the questions you have to solve when you're trying to do universal or isomorphic JavaScript is, where's your model data going to live when it's on the server? Where's it going to live when it's on the client and we rehydrate it? Do we have to make all of our modules context aware now? Does it have to know if it's running in Node? Does it have to know if it's running in the client? So one of the anti-patterns that kind of creeps up very quickly when you're writing universal JavaScript is something like this. So we have a function that's actually going to be isomorphic or universal. And we're going to have a variable called data. And the first thing we're going to do is check, are we going to be running in Node or not? So we're going to check if type of window is defined or not. And we're going to grab that data from browser context. Otherwise, we're going to grab that data from, I don't know, some require statement. Right? Our modules shouldn't be context aware. They shouldn't have to know where to get that data. So a way kind of to fix this is we actually have a function up here called context resolver. And this is going to know where to get the data from. And then we're going to create a variable called context resolver. And this is actually a bug here. This should say context, or this should be called CTX. And then we're just going to go grab that context and pass it into that isomorphic function. So this doesn't have to care anymore where that data comes from. So think of this function right here as your UI components or any other type of isomorphic function. All right, we're just going to pass in the context data to it and have a separate piece of information called context resolver that's going to go grab it from the right place. Another thing that's really helpful when writing universal JavaScript is using metadata to tell other modules what the UI needs. And I have the most context in React, so what we do in React is we use the statics method on a React component for this. So this is kind of taken right out of that account, my account page that I showed you. And here we're actually using it to load Flux stores. So here we're just going to use our statics, and we're going to create another property called meta on it, and then we're going to tell me what stores I need. So this doesn't have to know anything about what context it's in, and we're going to have a piece of middleware that runs on Node, or a piece of JavaScript that runs on the client that's going to actually know where to load these stores from, and it's going to use that context resolver to pull in the context and load all that information. Another thing we do with these statics, did anyone go to Jaffar's Falcor presentation? All right, so what we do in some of our components here is we use it to bind Falcor paths to components. So we can actually go ahead and make that automatic and dynamic. So we don't have to actually do anything with binding Falcor paths. It just happens because we have it in our statics. We also use it to load I18N strings. So we actually go ahead and have a meta strings, and we just load our bundles there. Now we don't have to care about where our bundles come from. We just go ahead and get them passed into our component as a prop. So the last step, kind of bringing everything together, is using something like Webpack and Browserify. Right? And this is kind of where you get the holy grail of code reuse, the holy grail of isomorphic universal JavaScript. So the nice thing that we can get out of universal, using Webpack or Browserify, is this code right here, where we're using the request object, can run on Node, and Browserify or Webpack will go ahead and shim anything that we need from Node into the client. So we can create this one package that will run with all of the exact same code. So we don't have to write separate code anywhere. We just write one code, and it knows where to run. So one of the things that people do when they start writing code like this is they have a separate Node code and they have separate browser code, right? Where the client code is bundled up into a Webpack bundle and the Node code is not. But the question I ask is, why not actually run these bundles in Node, right? So you actually have a much more unified experience. And it only takes a few configuration tweaks to actually do this with Webpack. And I stole a lot of this right from this blog post here by James Long. So if you want to run your bundles in Node, the first thing you have to do is collect up all of your Node modules. So you have to know what those Node modules are. And it's really easy to do. So you can do basically do a read dir sync, grab all your Node modules, and just actually add them to an object here. So we just have an object called Node modules. And then we're going to go ahead and tweak our webpack.config.js. So we're going to have one entry. We're going to actually export an array from our Webpack configuration instead of just exporting an object. And we're going to have our server.js entry with a target of Node. And we're going to have our web entry with a target of web. So now we have multiple targets. And then the only other thing we have to do is we have to tell Webpack to ignore our requires for Node modules. And we have to tell it to ignore our CSS because we don't want Node to do anything with CSS. So here we have our externals, which is our Node modules that we collected up in step 1. And then the next part is we actually use a plugin called Webpack.normal module replacement plugin. And we're just going to replace any type of CSS include with a no-op. So that's right here. And then the simplest thing is we just have to run that, or to actually run this code, we just have to run our bundle. So we just do node build server.js, and it'll run our bundle just like it would any other Node application. So a couple of last thoughts. The first thing is to start small when transitioning. So there are a lot of learnings that we can be had from a single page. When we started transitioning off of our Java stack to our Node stack, we brought in one page and did that first. And we learned a lot of things about where small bugs lie or how we could do things better at scale. So you don't have to do everything at once. And one way we do that, or one way we did that at Netflix, is we had a routing layer that would match a path. So for instance, I think it was WeGenre was one of the first pages we brought over. And we had a routing layer that would listen for requests to WeGenre, and it would route it to the new stack, or it would route it to the old stack. This way, if something went wrong and we really blew up the application, we would just turn off that route and go right back to the old stack. The next thing, iterate on modules. We all are engineers and we all want to do things perfect, but you don't have to do it perfect the first time. Learn from what you do and refactor as you go along and use those learnings to make it better. That's what we did with the account page. We learned a lot from that first big monolithic module we created, and we just kept iterating on it until we came to a place where we were really happy with how our modules were and how the pages were composed. Again, keep your code clean, right? It will be copied and pasted, so let's make sure that everything in a repository is clean, it's current, it's using the technologies that we're using right now. Automate, right? People are lazy. They're going to do the easy things and ignore all the hard things. So the thing like the get hook task that we have, automating that made it really easy to not give people an excuse for not running their get hooks before they push code up to the repository. These are the references, kind of some of the bits and pieces that I took out of where this presentation came from. So if you want to look up and go deeper in any of those, there's a couple of places I drew inspiration from. And does anyone have any questions? Yes? Can you repeat that? What's next for us? Yeah, so what we're going to do is we're going to keep iterating on all those modules we have. So we have those button components, we have input components, we have link components, but they're still not perfect. We still need to add things to them or make them do a little bit more things, make them less context aware. So we're just going to keep iterating on the things that we have and just keep learning from what we're doing. So we're bringing more and more pages over to Node. I think we're almost completely done with getting off the Java stack and in the Node stack. So we're just going to keep iterating and keep learning and keep bringing in new technologies and more ES6 whenever we can. right, well, thank you. These are my email addresses. If you want to know anything more about what I talked about or talk to me anything JavaScript, you can reach me at ranklam@netflix.com or ryan.anklam@gmail.com. And I'll hang around up here for a little bit too if anyone wants to come up and ask me any other questions.